This integral, when I worked out, I was really surprised that it's much complicated than I thought was. Now, it looks simple, just one log function, okay, and of course composite function. Well, I start with by parts. Okay, that is u. This is dv, so it becomes uv, u times v, from 0 to pi, minus v du. V is x, du is this derivative with respect to x, that is 1 over 2 plus cosine x, times the cosine dx derivative, which is a negative sign. That's why this becomes plus. So this is v du. Now then we plug x pi, this becomes log 1. So log 1 is 0, this is 0, so this first term is 0. Then my I, which is my original integral, is equal to this. In other words, this is my I. So I discuss this one instead of that. Now, to do this integral, I use a substitution. Let x be pi minus theta. Therefore, this x is pi minus theta. Sine pi minus theta is sine theta. And the cosine pi minus theta is negative cosine theta. And dx is negative theta. And the boundary then changed. Instead of from 0 to pi, it becomes pi to 0. And I use this negative to switch the boundary. So this negative is gone, it becomes 0 to pi. And this becomes two integral. One is pi times sine over this. The other one is theta times sine theta over this. So it becomes two integrals. Okay. Then this integral is easy. Is equal to log 2 minus cosine theta. Okay, that's easy. This integral, well, is not that easy. This integral is not that easy. Now, let me finish this term first. We plug pi there, it becomes 3. So the pi minus log 3, this is log cosine is 1, therefore log 1 is 0. So in other words, this term is pi log 3. And this integral, I change the dummy variable theta for x. It looks more comfortable. So in other words, my I is equal to pi log 3 minus this integral. I call this integral j. Let me call this integral j. Okay, I is equal to pi log 3 minus j. Therefore, I plus j is pi log 3. So this is my first equation. Well, I'm looking for I. And my I plus this one is pi times log 3. That is the first conclusion I have. Now, then I'm considering I minus j. This is j. Okay, this is I. This is I. This is j. So I minus j becomes this minus that. They have a common factor, x sine x, x sine x. So x sine x taken out, and this denominator minus this denominator minus This is I, right? This is plus. This is j minus. Therefore, it becomes this integral. And then we simplify this one by subtraction, and we get this. That's easy. Just simple algebra. And too much writing. This is the reason I pre-written to present. Now, then I simplify this one. This one is equal to minus 2x sine x cosine x 4 minus, this is 2, right? 1 plus cosine 2x dx. This is integral. And we multiply 2, both top and the bottom. This is minus 4 sine x cosine x dx. This will be 8 minus 1 minus cosine 2x. This is the reason I have this. 7 minus. See? So this is the reason. Well, yeah, this is and I use this 2 becomes sine 2. This becomes sine 2x. Therefore, this 4 becomes 2. So it's end up with this integral. Sine 2 theta is a 2 sine theta. This is a 4. All right, now, so we have this as my I minus j. Okay, so I continue from here. I minus j is this. Now, here, I let the y be 2x. This is I minus j. I substitute y for 2x. Therefore, this becomes 2y. This becomes y. Sine 2x is sine y. 7 minus cosine y. And dx is a half dy. Okay. All right. So it becomes this is my I minus j. Now then I split this integral into 2 parts. One is from 0 to pi, the other one pi to 2 pi. Well, this is nothing special. Just split this integral into 2. From 0 to pi, pi to 2 pi. Then here I'm considering this integral as a k. Okay. Then I discuss with k. K is this one. And I let y be 2 pi minus t. So this y becomes 2 pi minus t. Sine y will be sine t. And cosine y is cosine t. And dy is negative dt. Then I use this negative to switch that boundary from 0 to pi. So negative is gone. And it becomes 2 integrals. One is 2 pi times sine, which is this one. The other one is t times sine. This is this one. Okay. And this integral is easy. This integral is a log of 7 minus cosine from 0 to pi. This integral I keep it as is. Okay. And this, by substitute pi and a t there, you get this. And this, I just write dummy variable t for y. Okay. So this one becomes this. The reason, because this one is same as that one. In other words, this is the k. This is the k. If we plug this for k back, then this will be cancelled with that. So it's end up with I minus j becomes simply mean 1/2. This is negative half. This one only, because this cancel with that. Okay. So I find that I minus j is minus pi log 3 over 4 over 3. Then I work I is equal to half I plus j plus I minus j. I plus j we have had right here, right? This is pi over pi log 3. And I minus j is this. So it's end up with this. So that is the very answer to this integral, which I thought was easier, but is actually rather complicated. It might have other ways, but I don't believe they are easy. Thank you for your watching.